Hey everyone, and welcome back for another deep dive. Today we're going to be talking about something that's absolutely essential for human space exploration.
Ooh, I like this.
That's right. We're going to be talking about spacesuits.
Yeah,
The evolution of spacesuits.
love it.
From the very first early concepts of pressure suits to the incredible technology that's being developed right now for extravehicular mobility.
It's wild, right?
Yeah.
I mean, you're basically talking about like a personal spaceship.
Yeah, exactly.
Keeps a human alive in the most extreme environment imaginable.
It really is a tiny spaceship.
It is.
You've got life support, you've got all kinds of
Lots
stuff
of things
tucked
coming
into
in.
this suit. And what's so cool about following the evolution of the spacesuit is it mirrors our growing ambition
Yeah.
in space exploration as well.
Right.
From those initial forays up into the stratosphere
Yeah.
to the giant leaps we're making now
Yeah.
towards the moon and Mars and beyond.
Yeah.
Every era has demanded more.
Yeah. And more from these life support systems.
Yeah, it's been really cool to see that kind of technological evolution unfold right before our eyes.
Totally.
A lot of people don't realize that this journey actually started way back
Sure.
in the 1930s
It's true.
with someone named Wiley Post.
Lively Post. Yeah.
And his very first pioneering pressure suit.
And you can really see how this design laid the groundwork
Yeah.
for everything that came after.
Yeah, they were really grappling with a lot of the same issues
Yeah.
that spacesuit designers are facing today.
Pressure regulation.
Yeah,
Oxygen supply.
maintaining mobility within a constricted suit.
Absolutely.
Like they were working on a prototype for future astronauts.
They really were.
And speaking of astronauts, when the Mercury program came around, NASA needed some pretty specialized suits for those pioneering space flights.
Absolutely. And they adapted those high-altitude flight suits
Oh, really?
to the Mercury missions.
Hmm.
These suits were vital,
Mm.
but primarily they were designed for in-capsule use. They weren't really for what we call extravehicular activity or spacewalks.
Right.
It was a step forward.
Gotcha. So the first suits were more about keeping the astronauts safe inside the spacecraft.
Yeah.
Then along comes the Gemini program.
Yeah.
And all of a sudden, spacewalks become essential.
Yeah.
Was that the turning point where spacesuit technology really takes a leap forward?
It absolutely was, because they had to make that shift
Right.
from just surviving in space
Right.
to actually working
Yeah.
and exploring outside the spacecraft.
Yeah.
You know?
Yeah.
And so they came up with the Gemini G4C suit,
Okay.
which was designed specifically for this challenge.
No.
It had an umbilical tether system,
Oh, wow.
which enabled those first American spacewalks.
I can imagine that must have been a really incredible moment in history to see the first American astronaut flying freely in space.
Mm-hmm.
Those early spacewalks were really paving the way for even more ambitious missions later.
They did, and I think the most iconic example
Yeah.
is the Apollo missions,
Yeah.
culminating in those just amazing images
Yeah.
of astronauts walking on the lunar surface.
Iconic.
To accomplish this, they had to develop the Apollo A7L suit,
Mm-hmm.
and this was a marvel of engineering.
Yeah.
It had to have layers of thermal protection
Wow.
because of those extreme temperature swings
Yeah.
on the moon.
Right.
It had a portable life support system,
Right.
a PLSS,
Yeah.
and it had flexible joints
Yeah.
to allow those astronauts to move around
Yeah.
and collect those lunar samples.
The PLSS has always fascinated me.
Oh, yeah.
It's like a little miniature spaceship strapped to their backs,
A mini spaceship.
providing everything that the astronaut needs to survive in the vacuum of space.
Yeah.
It's mind-boggling
It's really remarkable.
how they fit all of that technology
Yeah.
into a portable backpack.
It was a self-contained
Yeah.
life support system. It regulated the oxygen supply. It
Yeah.
removed carbon dioxide,
Right.
maintained temperature control, and even provided communication capabilities.
It's like a miniaturized version of the entire
It really is
spacecraft's environmental control system.
a mini version. Yeah. It carried the oxygen tanks, a carbon dioxide scrubber, a water cooling system,
Mm-hmm.
and batteries to power all of it.
Yeah.
Incredible.
It's a lot to think about when you really consider what it takes to keep a human being alive in space.
Yeah.
It's not just about providing oxygen.
No.
It's really about creating a whole mini environment
Absolutely.
that mimics the conditions that we need to survive.
Yeah.
But space exploration didn't end there.
No, it didn't. Kept going.
Right. with the space shuttle program came new challenges
Mm-hmm.
and a new suit to match the
Yeah.
extravehicular mobility unit, or
Yeah.
EMU.
The EMU.
And this one is really incredible because it's actually still in use today.
Yeah. That's a testament to its design and its reliability.
It's really amazing to think that a suit designed decades ago is still up to the task of supporting spacewalks and International Space Station operations.
Well, it was designed for maximum mobility and protection
Yeah.
during those EVAs.
Yeah.
It has this complex layering system,
Yeah.
and each layer has a specific purpose.
Mm-hmm.
There's a thermal layer for insulation,
Okay.
a pressure layer to maintain the astronaut's internal pressure,
Right?
and a restraint layer
Huh.
that keeps the shape of the suit
Yeah.
and allows for movement.
It really is so much more than just a suit.
It is.
It's a life support system,
Yeah.
a protective barrier,
Mm-hmm.
and a mobile habitat,
That's it.
all in one.
Mm-hmm.
And we can't forget, of course, that NASA's not the only one
Oh, yeah.
that has been working on these
It's been a
global efforts,
It's been a global effort.
with contributions from other space agencies
Yes.
around the world.
I think the Russian space program is a
Yeah.
great example. They've
Yeah.
been developing these spacesuits for decades.
Mm-hmm.
The Orlan series
Yeah.
has been in use since 1977.
That's a long time.
They've continuously upgraded it
Wow.
and refined the Orlan design,
Yeah.
demonstrating their commitment to this technology.
That's a great point, that space exploration has always been a collaborative endeavor,
It have been.
with multiple nations contributing to our understanding of the universe.
For sure.
And it's not just governments anymore.
Mhm.
Commercial companies are also stepping into the arena. But before we venture into that world of private space exploration, I think we need to take a little break.
Okay.
We'll be back soon to explore the future
Mm-hmm.
of spacesuit technology and the challenges of designing for the unknown. So stay tuned.
It's good.
Welcome back to our deep dive into spacesuits. Before the break, we were talking about the global nature of
Yeah.
spacesuit development and how commercial companies are now entering the picture.
Mm-hmm.
But before we get to that, I want to delve a little deeper into the challenges of spacesuit design,
Okay.
especially as we look ahead to future missions, to Mars and beyond.
Right.
It's mind-boggling to think about the level of detail
Mm.
that goes into these suits.
Yeah.
We're talking about creating a miniature mobile, that life support system
Yeah.
that can withstand extreme temperatures,
Mm-hmm.
radiation, micrometeoroids, you name it.
It's a truly monumental task.
Yeah.
And it requires a multidisciplinary approach.
Oh, wow.
You have to bring together engineers,
Mm.
material scientists, physiologists, you could even argue fashion designers.
Okay, maybe fashion is pushing it a little bit,
Maybe.
but I'm sure astronauts appreciate a suit that looks at least somewhat cool
Right.
while they're out there making history.
Of course.
But in all seriousness, what are some of the biggest hurdles when designing these suits for deep space exploration?
Well, I think radiation
Yeah.
is one of the primary challenges.
Right, because once you get beyond Earth's protective magnetosphere,
Yeah.
you're exposed to all kinds of
You are.
solar and cosmic radiation. That can be really harmful.
Exactly.
So how do you even begin to shield against something like radiation?
Right.
Is it a matter of just adding more layers to the suit?
Not quite that straightforward.
Yeah.
It's really more about the type of materials you use
Uh-huh.
and how they're integrated
Mm.
into the suit's design.
Okay.
So you need to incorporate specific shielding materials
Right.
that
Mhm.
can absorb or deflect those particles.
Okay, so like lead is a great radiation shield,
Lead is great, but
but you can't really make a spacesuit out of lead.
no, you can't.
Okay.
It'd be far too heavy and
Yeah.
inflexible.
Yeah.
So it's this balancing act
Yeah.
between finding materials that provide adequate shielding
Right.
without compromising flexibility and mobility.
Makes sense. What about other environmental hazards like that Martian dust?
Oh, the dust.
That's got to be a concern,
That is a major concern,
especially on a planet like Mars,
especially on Mars.
where those fine abrasive dust particles
Yeah.
can really get into
They
everything.
can get everywhere.
Yeah, we're talking about clogging of joints, scratching of visors,
All of it.
even contamination of life support systems
Right.
if that dust gets inside.
Yeah, it's a real challenge.
That sounds like a nightmare scenario.
It is.
And I'm just picturing that red dust getting everywhere.
They're getting everywhere.
So how do they deal with that?
Well, they're developing advanced dust mitigation technologies.
Yeah.
Special coatings to prevent the dust from sticking,
Huh?
air filtration systems to remove those particles
Mm-hmm.
from the suit's internal environment.
Right.
Even electrostatic charge systems
Wow.
that could repel dust.
It's amazing the amount of thought that goes into every little detail.
It is.
And I imagine the gravity difference has to factor into the
What?
suit design as well.
Yeah, absolutely.
Because we've got the moon, which has about 1/6
Mm-hmm.
the gravity of Earth.
Right.
Mars has a completely different
Right, that's so
gravitational
great.
pull.
Yeah.
It's about 3 times that of the moon. So we have to kind of rethink
Yeah, we do.
how the suit supports the astronaut's body.
We have to rethink how they move.
Yeah.
All of it.
It's funny to think that after decades of designing suits for microgravity, we now have to kind of go back to the drawing board
Yeah.
and figure out how to walk on a planet again.
How to walk again. It is a full circle.
It is.
The joints, the pressure regulation, the center of gravity, all of those things need to be recalibrated
Right.
for Martian conditions.
It's not just the physical environment either.
No, it's not.
There's also the psychological impact of being in such an isolated and extreme environment.
That's true.
To be out there in this vastness of space,
Yeah.
millions of miles from Earth, enclosed in this suit, with really nothing but the sound of your own breathing.
Yeah.
That's got to be pretty intense.
You're touching on a really important point.
Yeah.
The psychological well-being of astronauts is paramount.
Right.
The isolation, the sensory deprivation, the constant awareness of the risks, all of that can take a toll.
So how is spacesuit design evolving to address these factors?
Well, there's a growing focus on features that enhance comfort,
Okay.
communication,
Oh.
and even provide a sense of connection to the outside world.
So are they trying to make the suits more user-friendly?
In a way, yes.
Okay.
More comfortable, perhaps.
Yeah.
They're developing better communication systems, higher resolution displays inside the helmet,
Yeah.
so they have more visual information,
Okay.
and even experimenting with haptic feedback systems
Wow.
that can simulate a sense of touch.
It's like they're trying to create a virtual reality environment
It is.
inside the suit to combat that isolation.
Right.
It's really interesting how technology and human psychology are merging in these designs.
They're coming together for sure.
It's clear that spacesuit design is incredibly complex, and the challenges are only going to become more challenging.
More challenging as we go
Even
further.
as we set our sights on deeper space exploration.
It's true. And the suits will have to evolve
Yeah.
even more dramatically. They'll need to be more robust, more adaptable, and more intelligent to handle the unknown.
It's really amazing to see the ingenuity of the people designing these suits.
Oh, it's incredible.
It seems like it's just as boundless as the universe itself.
Yeah.
Hearing about all of this, it makes me feel a little claustrophobic.
Oh, yeah.
I can't even imagine what it's like to actually be inside one of these suits,
Yeah.
millions of miles away from Earth. It's really a testament to the astronauts
Okay.
who are willing to put themselves in that position.
Mm-hmm.
They are a remarkable group of people.
They are.
And thankfully, they have these incredible suits to keep them safe and functioning out there on the final frontier.
For sure.
But I think we need to take another little moment
Okay.
to let all this information sink in. We'll be right back. To wrap up our exploration of spacesuits and look ahead to what the future might hold. Welcome back to the Deep Dive. We've been on quite a journey through the world of spacesuits.
Yeah, it has been fascinating.
From those very first pressure suits to the incredibly complex systems we have today, it's amazing how much ingenuity and work
Yeah.
goes into keeping humans alive and functioning in the harshest environments imaginable.
And now we're going to talk about commercial spaceflight.
Yes, that's what I'm really excited about.
Oh, yeah.
Because it seems like these commercial companies are really shaking things up.
Yeah, they're injecting a whole new wave of innovation.
What kind of impact are they having on spacesuit design?
Well, some companies
Yeah.
are really focusing on creating suits
Yeah.
that are much lighter
Okay.
and more flexible than their predecessors.
Like a second skin, kind of?
Almost like a second skin.
Yeah.
They're using advanced fabrics,
Mhm.
3D printed components, even bio-inspired designs.
Bio-inspired designs. What does that even mean when it comes to spacesuits?
Well, imagine suits that can mimic the
Oh.
flexibility and resilience of biological organisms.
Wow.
So they might incorporate self-healing materials,
Wow, that would be incredible.
adaptive structures that respond to pressure or temperature, even embedded sensors
Yeah.
that monitor vital signs.
It's like blurring the lines between biology and technology.
It is, for sure.
What about artificial intelligence?
Well, some companies are exploring how AI could help astronauts during those spacewalks.
Okay.
Imagine a suit that can anticipate your needs,
Okay.
provide real-time guidance or feedback, even take over certain tasks.
So the suit's kind of thinking for itself?
In a way, yes.
That's
It
wild.
frees up the astronaut to focus on more complex things.
It's like something straight out of science fiction.
I know, right?
An AI-powered spacesuit.
But these are the kinds of ideas being explored today.
Yeah, it really makes you wonder what's next. Like, what could come after that?
What is next?
Are we going to have suits that can make us coffee
Uh-huh.
while we're floating around in space?
Who knows?
Yeah.
The possibilities are really exciting.
Yeah, and as we venture further into space, the need for these advanced suits is only going to become more important.
More and more critical.
These suits are more than just pieces of equipment. They're really guardians of human life out there in these extreme environments.
They allow us to push the boundaries of exploration and to do research and expand our knowledge of the universe.
So as we wrap up this deep dive, I want to leave our listeners with a final thought.
Okay.
We've talked about suits for the moon and Mars and deep space. But what about environments that are totally different? Like, what about suits for underwater exploration?
Oh, wow.
Or for going into volcanic craters?
Yeah.
You know, maybe even for exploring the depths of our own oceans.
That's a great question.
Yeah.
It highlights that this technology has applications
Yeah.
way beyond space exploration.
That's a really cool idea.
We're developing these advanced life support systems that could be adapted for any extreme environment.
Right. It doesn't have to be space.
Exactly.
It could be the bottom of the ocean. It could be a volcano. It's really about protecting
It is.
the human explorer wherever their curiosity might lead them. And that's an inspiring thought to end on. So keep looking up, keep exploring, and keep pushing the boundaries of what's possible. This is The Deep Dive, signing off.